A very warm good afternoon to all of you. This is Maria Pushpam, and hope you are able to understand the previous things what we have seen. We have previously seen the basic terminologies used in errors and data analysis, that is mean, median, mode, range, deviation, mean deviation, then relative mean deviation, standard deviation, coefficient of variation, and variance. So I think you are able to understand these terminologies very clearly. These basic, we can go with the next topic, and for today's class we are going to see something about accuracy and precision, the difference between accuracy and precision, and finally I'll conclude with error analysis. And in error analysis again we have two topics. One is absolute error and relative error, and the problem based on these accuracy and precision. I'll go with precision first. Okay, so first we can see what is said to be precision. So from the term itself you can understand precision is nothing but it is a very close, it's very it's a concordant value among the given value. I'll repeat. So precision refers to the agreement or concordance among a group of experimental values. If you are having a group of experimental values, what we say as a precise value is value which is being repeated one or more times. For example, the thing what I have given here is the values are 19.2, 19.3 and 19.2 are the values obtained in three separate titrations, and what is the precise value we take into account is 19.2. And from this example you can understand what is said to be precision. So precision is nothing but it's a terminology, or it's a term used to specify the value which is very close to the experimental value in a group of value. If it is given, the value which is found to be repeatedly which is coming, we take it as the precise value. So precise value is the one which is obtained more than one time in an experiment. This is a very accurate definition. I'll repeat. So precise value is the one which is obtained more than one time in an experiment is called as precise value, and the thing is called as precision. So example you are able to follow. I'll repeat. So 19.2, 19.3 and 19.2 are the three different values obtained in a titration, three different titrations, and what we take as a precise value or precision, it's nothing but 19.2 is taken as a precise value, or in other words it is called as precision. Okay. Next one, we can see how to express this precision. So you are able to understand what is precision. Precision is nothing but the term which is coming again and again, or the value which is coming again and again in an experiment. Repeated, if you are doing 10 or 5 experiments, the value which is found to be coming again and again, we take it as the precise value. And normally it is being expressed in terms of mean deviation, or we can use the term relative mean deviation. And you know the formula for mean deviation. Mean deviation is nothing but sum of xi minus x bar divided by n, and you know xi is nothing but the individual value and x bar is the mean value divided by number of terms. So you know this thing we have studied already. So mean deviation is nothing but sum of xi minus x bar divided by n. This we call it as mean deviation. And another one we are normally using is relative mean deviation. It is expressed with PPT. PPT is nothing but parts per thousand. It's given by the formula mean deviation divided by mean into 1000. Mean deviation divided by mean into 1000. So this will give you the value of precision or precise value. So if you need to find the precise value, what you have to do here is you take the mean deviation value. From the mean deviation value, you divide the mean value, then you multiply by 1000, you get the relative mean deviation value, and this we call it as precision value or precise value. Next thing what you are going to say is, if the mean deviation is found to be smaller, the precision will be greater. Precision will be greater. So if you have a lesser mean deviation, precision will be a good, or it's a greater precision. Next one what you are going to see is precision is better. It's expressed in terms of standard deviation other than mean deviation. The main reason is mean deviation will be a positive or a negative value. If you take standard deviation, surely it will be a positive value. So I'll repeat the point once again. So normally what I mean by precise value is, precise value or precision is nothing but the value which is being repeated in an experiment again and again. That is more than one time. If a value is being repeated, we take that as the precise value. And precision is normally expressed in terms of mean deviation or sometimes in terms of relative mean deviation. I have said you both the formulas here, how to calculate mean deviation and how to calculate relative mean deviation. Now we are going to see what happens if precision is found to be if mean deviation is found to be smaller or greater. So what is the terminology given here is, if mean deviation is found to be lesser, the precision will be a good one, the value will be a good value. Is it okay? So now what you are going to say is, precision is better to be expressed in terms of standard deviation rather than mean deviation. The main reason behind this is, if you take the both of the things, mean deviation will be, sometimes it will be positive, sometimes it will be negative. But if you take this standard deviation, surely it will be a positive one, because you know the formula for standard deviation, it's nothing but square root of xi minus x bar divided by n the whole square. So because we are squaring the value xi minus x bar the whole square, the difference the whole square, you'll get a positive value. So answer will be surely a positive value. So standard, it's better to explain this precision in terms of standard deviation. Now we can see problems correlated to this. Is it okay? So what's the problem we are going to see here is, normality of a solution is determined by 3 separate iterations and the values obtained are 0.2041, 0.2049, 0.2043. And now we have to calculate the accuracy and precision of the result if the true value is given as 0.2042. In the previous class, we have seen what is said to be accuracy. Accuracy is nothing but it's a value which is near to, very close to the original value. We call it as accuracy. Is it okay? And how we have calculated, it's nothing but the difference between the individual value and the true value. The true individual value is nothing but the experimental value is called as individual value. So experimental value minus true value will give it the accuracy. So now what you are going to do here is, the true value is given in this problem and 3 different values are given. We need to calculate what is said to be accuracy and what is said to be precision. First, what you have to do here is, you are in need of the true value, then you are in need of the mean value. So what you have to do here is, first you take the true value. You have to write the things given there. So true value is nothing but, it is clearly it is given, it is 0.2042 is given as the true value. Then we have to find the mean. All of you know how to find the mean. I have taken in this unit, the starting I have said what mean is. Mean is nothing but the average of the given value. So you sum up all the values. So number of terms is said to be 3. So you divide by 3. The answer is nothing but 0.2044. And normally I have said you already, this accuracy is mentioned only by relative mean error, and it's having the formula mean value minus true value divided by true value into 1000. This is meant for accuracy. Accuracy, the formula is nothing but, actually it's represented by relative mean error. Relative mean error. So remember a point very clearly. If accuracy is being asked, you have to specify the term relative mean error, and if precision is being asked, you have to take into account relative mean deviation. Don't confuse both the things. I'll repeat. So 2 things we need to calculate. One is, the one term asked is nothing but accuracy, another one is nothing but precision. Okay, so I'll say how to remember this. So if a problem is given, some values are given and true value is also given, and they have asked 2 things to calculate. One is accuracy, another one is precision. Before going into the problem, you have to see what are the terms given, and you have to see what is the formula to be used for this particular problem. So 2 things are asked. One is accuracy, another one is precision. So I have said you, for accuracy we are in need to calculate relative mean error. Relative mean error, and for precision we need to calculate relative mean deviation. Don't confuse, one is relative mean error, another one is relative mean deviation. So what's the formula for relative mean error is nothing but mean value minus true value divided by true value into 1000, because relative mean error is calculated only in the form of PPT, that is nothing but parts per 1000. So we use in the formula we are using the term 1000. So mean value minus true value, the whole divided by true value into 1000, and our mean value is nothing but 0.2044, and our true value is given in the problem, it is 0.2042, the whole divided by 0.2042, you get a value, then you multiply by 1000, you get the answer as 0.979 ppt, which is nothing but parts per 1000. So I'll repeat the thing once again, ma. So the thing given is 3 different values are given and the true value is also given. Is it okay? So what you have to do to calculate the relative mean error is, first you calculate the mean value. For all the things we are in need of the mean value, whatever it is. If it is relative mean deviation or it is relative mean error, for both the things we are in need of what we call it as mean. So mean is nothing but, initially I have said you what mean is nothing but the average of the given value we call by the word mean. So average, so 3 different titration values are given, you sum up all the 3 values, after summing up you divide the value by 3, so you get the answer there, you multiply, you divide the whole thing by the, so that is the average. And for relative mean error, the formula you are using is mean minus true value divided by true value into 1000. This will give you accuracy, and substitute the values. Values are nothing for mean. For mean, we have got 0.2044 minus true value is given already, 0.2042 divided by 0.2042 multiplied by 1000. You get the accuracy value as 0.979 ppt. 0.979 ppt. Now we are going to see how to calculate the precision value. So you know how to calculate precision. Precision, I have said you already, precision can be calculated only by using relative mean deviation. So for calculating relative mean deviation, what are the things we are in need of? We are in need of mean value, then we are in need of mean deviation. Using that only we can calculate relative mean deviation. So I'll go with precision. So for precision we are need of 2 things we are in need of initially. One is mean, another one is mean deviation. With these 2 values we can calculate the relative mean deviation, because relative mean deviation is nothing but mean deviation divided by mean into 1000. Mean deviation divided by mean into 1000. This will give you the thing called as precision. Is it okay? So previously we have seen clearly about accuracy, and now we are going to see clearly about precision. I'll repeat, ma. So because these problems are very important and it's easy to calculate. So I'll repeat the thing so you can understand very easily as you are listening in the class. Okay. So first we have already calculated the mean value. So there is no need of repeating the same thing again. So we know the mean value. Mean value is nothing but 0.2044 is said to be the mean value. Using the mean value we can find mean deviation, because we know the formula for mean deviation we have studied previously. Mean deviation is equal to sum of xi minus x bar divided by n. I'll repeat, mean deviation is nothing but sum of xi minus x bar divided by n. So what you have to do here, you put a tabulation, you find the values, difference between the experimental value and the mean value. After finding the thing, what you have to do here is you do the summation of all the things, you divide it by 3, you get mean deviation. And from this mean deviation you can easily find the relative mean deviation, because relative mean deviation is nothing but mean deviation divided by mean into 1000. It is also expressed in terms of parts per 1000. It's clear? Okay, so now I'll go with the relative mean deviation. So relative mean deviation is nothing but mean deviation divided by mean into 1000. So mean deviation is the value for us, it is given as 0.0003 divided by mean we have already calculated in the previous step. It is 0.2044 multiplied by 1000. We get the answer as 1.46 ppt. 1.46 ppt. I'll repeat the same thing once again. So previously I have said you how to calculate this accuracy. So accuracy is nothing but it's a relative mean error, we call it as accuracy. It is how to find the value is experimental value, that is nothing but mean value minus true value divided by true value into 1000. I have said you how to calculate it very easily. Next we are going to see about precision. And precision, what are the terms we are in need of is we are in need of mean and mean deviation. So mean we have previously calculated, and how to calculate mean deviation, the formula is nothing but sum of xi minus x bar divided by n. Xi is nothing but the individual value. You have to subtract the individual value from the mean value for all the three things. Then you divide the whole thing by n. N is nothing but 3 values, so it is 3. The answer is equal to 0.0003. That is a mean deviation. Now we will go with the relative mean deviation, which is called as precision. So precision is equal to, or relative mean deviation is equal to mean deviation divided by mean into 1000. We get the mean deviation value as 0.0003 divided by 0.2044 multiplied by 1000. Our answer is 1.46 parts per 1000 ppt. It's clear? I'll go with the next topic, ma. So I think you are clear with the accuracy and precision problem and how to calculate it. I have clearly explained. So go with the next one. I'm going with the next one. Next is the difference between accuracy and precision. So only 3 points we are going to see here. It's very simple. First one is the nothing but the definition. So what I mean by accuracy, I have said you accuracy. Accuracy is nothing but it gives a closeness of the measured value and the true value. That is, it shows it's very close to the measured value is found to be very close to the true value. This we call it as accuracy. For example, you can guess if you do a titration, the actual value is found to be 90. Is it okay? And you are doing so many titrations, so you are getting the value as 89.4, 89.5, 89.6. 3 values you are getting 89.4, 89.5 and 89.6. And accuracy value what we can take here is 89.6 because it is very close to the true value. So this closeness of the measured value with the true value we call it as accuracy. That's the definition there. You can understand? Yes? Okay. So it gives a closeness of the measured and the true value we call it as accuracy. And what I mean by precision, I have said you, it gives a closeness of the measured value in a series of experiments. So again I am saying, if you take how to find the precision value is, we are doing an experiment. Now we are doing 3 different experiments. Okay, one value is found to be 10.5, again it is 10.4, again it is 10.5. And normally what we take is a concordant value said to be the precision value or precision. It is nothing but 10.5. Is it okay? So this we call it as precision. So how to define precision is, precision gives a closeness of the measured value in a series of experiments. You are doing a lot of experiments, and in that series which is found to be repeatedly coming, we call it as the precision value. Second difference is, it is used to express the correctness of the measurement. How correctly we have measured, this will express, that is accuracy will express. And here it is used to express the reproducibility of the result. Reproducibility means one thing coming again and again. Normally in lab we do titrations, and what we take as a concordant value is a repeated value. That is concordant value. Normally you know what is concordant value. It is nothing but the repeated value. We take it as the concordant value, and that is said to be precision. It is nothing but is used to express the reproducibility of the result. Is it okay? And third one, I have said you already, accuracy is measured in terms of relative mean error. Relative mean error, and precision is measured in terms of relative mean deviation. Relative mean deviation. It's clear? So first point is closeness of the measured value with the true value, we call it as accuracy, and if the measured value is being repeatedly coming in a series of experiment, we call that is the precision. And second point is it is used to express the correctness of the measurement. It is used to express the reproducibility of the result. And last point is accuracy is expressed in terms of relative mean error, and precision is expressed in terms of relative mean deviation. Next topic what you are going to see is error analysis. So we have seen what are the different ways of finding the value. One is accuracy, another one is precision. So accurate value, precise value. Okay, so now we are going to see error analysis. So what I mean by error normally, we used to calculate in lab that error, yes, this much percentage of error you are getting in this titration. How we do normally, we get the difference between the skilled value and the experimental value, what you are doing, that we call it as error. Same thing it is mentioned here. So error is defined as the difference between the measured value and the true value in a chemical analysis. This we call it as error. Now you remember we calculate normally if you are doing a titration in the first year we do volumetric analysis, and you remember that we used to put errors. Okay, you are able to remember that, right? So what I mean by error there is, what is the term we use error there is the difference between skilled value and the experiment what you are doing. Those two values will have a difference, and that difference, if it is found to be nil, we say it is nil error, no error is there. If something difference is there, we call that particular thing as this much percentage of error is present in this experiment, we used to say, and we allocate marks, right? Same thing we are saying here. So error is defined as a difference between the measured value and the true value in any chemical analysis, and it is expressed in two ways. One is said to be absolute error, another one is said to be relative error. I'll define the term once again. In the previous class I have said you, in accuracy I have specified these terms. So one is said to be absolute error, another one is said to be relative error. So what I mean by absolute error is, absolute error EA is equal to xi minus xt, xi minus xt. So how to calculate this absolute error is, it is nothing but the individual value minus the true value. So this will give you the absolute error. It's clear for you? So what I mean by absolute error is, it's a difference between the individual value and the true value. We call it as absolute error. So now we'll see what is said to be relative error. Relative error is nothing but the ratio of absolute error to true value. We call it as, I'll repeat. So what I mean by relative error is nothing but the difference between two things. That is, it's a ratio between two things. One is nothing but absolute error, we have already found, divided by true value will give you the thing called as relative error. I'll repeat ma. So what I mean by the absolute error is a difference between the individual value and the true value is called as absolute error. And now what you are going to say is relative error. So relative error is defined as a ratio between absolute error and the true value. So absolute error we have already calculated. You divide the thing by true value, we get the term called as relative error. And if you take relative error is normally expressed in terms of percentage or parts per thousand. So I have said you already, if it is a percentage term, what you do there is you multiply the answer with 100. And if it is parts per thousand, you multiply the answer with 1000. It's clear? I'll repeat the point once again. So relative error is nothing but absolute error divided by true value. And absolute error is nothing but experimental value or individual value minus true value. We call it as absolute error. And absolute error divided by true value will give you the relative error. Is it okay? And now if you take this relative error is expressed in terms of percentage and sometimes in terms of parts per thousand. Okay, so coming to this thing, how to remember the point is, you calculate the error as same as the relative error. What you calculate the value. After calculating the value, if you are multiplying the answer by 100, we say the relative error is given in the form of percentage. And if you are multiplying the answer by 1000, we say it is given in the form of parts per 1000. It's clear? So now we can see the problem related to these errors. So the question is, calculate the absolute error and the relative error in PPT. I have said you. So for final answer you have to multiply by 1000. That is PPT. For the values, 5.2 things are given. One is 5.431. Another one is 5.410. So you remember point here. What you have to do here is you have to assume the values which is found to be the true value and which is found to be the experimental value. True value and the experimental value. You have to assume, and assuming that only we can do the thing. Is it clear, ma? So you take the experimental value as a higher value. It's nothing but 5.431 is said to be the experimental value, and the true value is found to be 5.410. So we have to assume and do this thing because nothing is given over there. They have simply asked find the absolute error as well as the relative error in PPT for two values they have given. So what you have to do if such problems are asked is you take the lower value as a true value and higher value as the experimental value. So what you have to do here is you take the experiment, how to calculate absolute error is nothing but, I have already said you, what do you mean by absolute error? It's nothing but individual value minus true value. It's experimental value minus the true value. So what do you have to do there? 5.431 minus 5.410, which is nothing but 0.021. 0.021. So this is absolute error. I have said you the formula for the previous thing, how to calculate relative error. Relative error is nothing but absolute error divided by true value into 1000. So you substitute the value divided by true value into 1000. We get the answer as 4.8817 PPT. So this is something about this problem. I think you are able to understand this. So absolute error is nothing but xi minus xt, and relative error is nothing but xi minus xt divided by xt, or simply you can call this absolute error divided by true value into 1000 will give you the relative error. Is it okay? So I'll warm up the thing what you have seen for today's class. The thing, what are things we have seen for today's classes? What is precision and how it can be calculated, followed by the difference between precision and accuracy. Then we have seen what is error analysis and the difference between absolute error and relative error, and how to calculate this absolute error and relative error. I think you are able to understand very clearly. Thank you for patient listening. Continue studying. Thank you, ma.